A very good morning to one and all. Now, myself Chianusha, working as lecturer in physics, and I'm working under Department of Technical Education, Telangana. At present, I'm working at SS Government Polytechnic, Zahirabad, and I'm working in general section. The subject what I'm dealing for first year, second sem students is applied physics. The subject code of this is 18 common 203F. The topic what we are discussing here is electricity and measuring instrument, which is fifth chapter from our syllabus. Now in today's session we are going to learn about specific resistance and conductance with their units. Now to learn this, I am taking help of PowerPoint presentation. The main objective of today's session is, on completion of this period, you will be able to learn what is specific resistance, what is conductance. Now, before moving on to today's session, let us recall what we learned in the previous session. Now, in the last class, we studied about ohmic and non-ohmic conductors, and also we learned about temperature coefficient of resistance. Now, ohmic are the conductors which obey Ohm's law, and non-ohmic conductors are the conductors which does not obey Ohm's law. Now, temperature coefficient of resistance is the resistance of the material depends on the temperature. Now, depending upon this dependence, this coefficient is of two types, positive and negative. For metals or conductors, it is positive, and for semiconductors and insulators, it is negative. Now, what is specific resistance, or which is also known as resistivity? Now, to understand specific resistance or resistivity, the resistance of a conductor depends upon dimension of conductor and material with which it is made, and also it depends on temperature of the conductor. Now, it is found that at constant temperature, the resistance of the conductor is directly proportional to its length and inversely proportional to area of cross section of the conductor. Now, if we write this proportionality, R is proportional to length and R is proportional to 1 by A, as it is inversely proportional, we are considering it as 1 by A. Now, when we combine these two proportionalities, R is proportional to L by A. Now, if we take it out proportionality, R is we are getting one constant, that is rho. So, R is equals to rho into L by A. Now, this rho is specific resistance or resistivity. Now, see here in the expression, if L is equals to 1 and A is equals to 1, so what is R? That is equals to rho. Now, we can define specific resistance as, it is the resistance of a conductor of unit length and unit area of cross section. Now, what is SI unit of specific resistance? Specific resistance or resistivity is expressed as ohm meter. Now, symbolically it is ohm meter. What is conductance? The reciprocal of resistance is conductance. So, reciprocal is simply conductance is equals to 1 by resistance. Now, what is conductance definition? The ratio of the current passing through a conductor to the potential difference developed across its ends is called conductance of the conductor. Simply it is V by I is equals to R. Reciprocal of R is I by V. That is conductance. Now, unit of conductance is Siemens. Remember this, the unit of conductance is Siemens. I think it is, or simply we can say ohm inverse. Now conductivity or specific conductance. The reciprocal of resistivity is called conductivity or specific conductance. So conductivity sigma, which is equals to 1 by resistivity, that is 1 by rho. The conductivity of the material is defined as conductance of the conductor of unit length having unit area of cross section at constant temperature. Now what is unit of conductivity? The SI unit of conductivity is Siemens per meter. So this is about resistivity or specific resistance. Now this is a very small discussion. We are just learning about only few definitions. They are about specific resistance, specific conductivity. Now as we learned in the previous session about resistance, now this resistance is depending upon length of the conductor and it is depending upon area of cross section of the conductor. The dependence is R is directly proportional to L and R is inversely proportional to A. Now combining these two, we got an expression for specific resistance as R equals to rho into L by A. Now if this L and A are equal to 1, then rho is equals to R. Depending upon this, we define specific resistance as the resistance of a conductor of unit length and unit area of cross section. Now very important expressions. This formula, let me write by using this formula, rho is equals to R into A by L. This is very important expression. And its unit ohm meter. Now the reciprocal of resistance is conductance. Unit of conductance is ohm inverse or Siemens. Now the reciprocal of resistivity is conductivity. The unit for this is Siemens per meter. So what we discussed in this session, we have discussed about specific resistance and its unit, conductance and conductivity and their units. Now the reciprocal of specific resistance is specific conductance or conductivity, which is expressed by sigma. The sigma is equals to 1 by rho. Now as I have written the formula or the expression for rho as R into A by L, so reciprocal of that is L by R into A, that is expression for conductivity. So let us see, specific resistance is expressed in ohm, ohm meter, voltmeter, none of the above. It is ohm meter. Next, resistance depends on length, pressure of conductor, length, area of cross section of the conductor, length, area of cross section and temperature of conductor, none of the above. It depends on length, area of cross section and temperature of conductor. What is unit of conductivity? Siemens, Siemens meter, Siemens per meter, none of the above. It is Siemens per meter. Now, what are symbols for resistivity and conductivity? Rho and sigma, ohm and q, ohm and v, none of the above. That is rho and sigma. Now, here are some frequently asked questions. Derive an expression for resistivity of a conductor and state its SI unit. So we derived an expression by using the relation between R and L, R and A, where L is length of the conductor and A is area of cross section of the conductor. Now by using their relations that R is directly proportional to L and R is inversely proportional to area of cross section, we can derive an expression for resistivity and also its SI unit, that is ohm meter. Define conductivity and state unit of conductivity. So with this I am concluding class. Thank you so much for listening it. I hope you are very clear with this topic. We learned about specific resistance, which is also known as resistivity, and also we learned about conductance, which is reciprocal of resistance, and the reciprocal of specific resistance is specific conductance, which is simply reciprocal of resistivity, that is conductivity. So with this I am concluding. Thank you so much for listening class. I hope this class is useful for your learning practice. Thank you so much.